If you build software and someone has just asked you to add an AI feature to it, this video is for you. You don't need to know how these models are trained. You don't need any maths. You just need to know how to talk to one from your own code, and that is a much smaller thing to learn than it looks from the outside. Let's walk through it slowly. Let's start with what a large language model actually is. Underneath everything, it does one small thing. It reads the text so far and it guesses what comes next. Not a whole answer at once, just the next little piece. A token, which is roughly a word or part of one. Then it adds that piece to the text and guesses again and again. Everything you have seen these models do comes out of that one habit repeated very fast. Now the part that matters for building things. Your code almost never runs the model itself. The model lives on someone else's computer, behind a web address. So, you talk to it the way you would talk to any other service. You send a request, some JSON, over HTTP. You get a response back. That is the whole interface. Messages go in. A completion comes out. If you have ever called an API, you already know how to do this. Here is a piece of good luck. Almost everyone agreed on the same shape for that request. It came from OpenAI's chat completions endpoint and it spread. A model name, a list of messages, a temperature if you want the answers more or less predictable. Other companies copied it. Open source projects copied it. The tooling assumes it. So when you learn this one shape, you have quietly learned how to talk to almost every model out there. Look closer at that list of messages. Each one carries a role. The key system, sometimes called developer, is where you, the engineer, set the rules. Who the assistant is, what it must never do, what shape the answer should take. User is the question in front of you right now. Assistant is what the model said last time. A simple habit that will serve you well. Durable rules go in the system message. The task of the moment goes in the user message. Which brings us to the thing that surprises people most. The model does not remember you. Every request starts from nothing. It knows only what is in the messages you just sent. When a chat seems to remember what was said 5 minutes ago, that is because the application sent it all again. So, memory is your job, not the model's. You store the conversation. You decide what to include next time. Usually, that means keeping the system message, the last few turns, and a short summary of the rest. Now the piece that turns a demo into a product. By default, a model replies in ordinary prose, lovely for a human, painful for a program. If your code has to dig a name and a date out of a paragraph, it will work on Monday and break on Tuesday. So instead, you hand the model a schema, a description of the shape you want. These fields, these types, nothing extra. And the reply comes back in that shape, not usually, every time. The required fields are there, numbers are numbers. Nothing unexpected sneaks in. You can pass it straight to the rest of your code without a single defensive parse. It is worth knowing why that guarantee holds because it is rather elegant. Remember, the model picks one token at a time. Before each pick, your schema is used to cross out every option that would break the shape, a closing brace where a number belongs, a field name that is not in the schema. The model can only choose from what is left. It is not being asked politely to return good JSON. It is being held to it. That is why this is dependable and why older tricks were not. One last thing, so you never feel trapped. You are not tied to any one company. There are excellent open models now, Llama, Qwen, Mistral, and others. You can run one on your own laptop with a tool like Ollama or on your own servers. And because nearly all of them speak that same request shape, switching is a small change. You point at a different address, you use a different key, your code stays as it is. So that is the ground floor. A model that guesses the next token, a web request carrying a list of messages, roles that separate your rules from the user's question, history that you keep, and schemas that make the answer safe to use. Everything else in this series is built on those 5 ideas. Next time, we give the model something new, the ability to call your own code and do things in the real world. See you there.